So we are starting our new unit. We are splitting up the geometry test because it is a whole lot of material for geometry. We cover angle relationships, we cover cross sections, we go over circles, we go over area, we do volume, we do surface area. It's just a whole lot of material for geometry. So we are going to be splitting geometry up into, for you guys, 3 parts. Okay, your first test is going to be only on angle relationships and on cross sections, so it's really, really small. So we'll most likely be testing, obviously not next week, but the week after. We will definitely be testing once you guys come back from break. We'll do like a quick review and then test. Then we will cover circles, area, volume, and surface area. That will be on the second test, and then later in the year we'll return to geometry and we'll cover part 3 of geometry, which is Pythagorean theorem, which is dealing with just right triangles. We're not going to cover that right away just because it's not on your exams, nor is it going to be on milestones because it's an 8th grade material. So it's a lot of stuff inside of geometry. Just make sure you understand we're really only going to be doing 2 actual lessons, 2 actual sections of notes that will be on your first test. So this being one of them. So you will be taking a quiz on this next week. So you want to make sure that you're prepared for that quiz and that you've got everything covered down. And then we're going to do a whole bunch of just in-class assignments working together through some like Google Slides or things like that. In order to be able to be knowledgeable with our angle relationships, you have to know how to solve equations, because geometry's angle relationships is all about creating equations. So that's why we have a warm-up going over our equations. So we have examples of 2-step equations, equations with distributive property, and other versions of multi-step equations or variables on both sides. So for problem number 1, we have 7x minus 8 is equal to 20. What did you get for problem number 1, Jimez? X equals 4. Very good. So what we're going to do first is we're going to add 8 to both sides of our equation. That way we can go ahead and start isolating our variable. That leaves us with 7x is now equal to 28. And then from there we can go ahead and divide both sides by the 7, and we get x is equal to 4. What about for problem number 2? What does x equal for problem 2, Iker? X equals 8. Very good. So we're going to subtract 11 from both sides first. That's going to leave us with 3x is now equal to 24. And then we will divide both sides by 3 and get x is equal to 8. Okay, for problem number 3, what did you get? Elijah, what did you get for number 3? X equals 64. Very good. So we are going to add 9 to both sides. By adding the 9 to both sides, that leaves you with x over 4. X divided by 4 is now equal to 16. Then all you need to do is multiply both sides by 4, and you'll get x is equal to 64. Okay. Problem 4, we've got those distributive property problems. Kingsley, what do we get for problem number 4? X equals 2. Okay, so the first thing that you're going to have to do is distribute. That means you're multiplying that 5 times the 4x and that 5 times the negative 3. Remember, that was a negative 3. That minus 3 becomes like a negative. Why can't I get that in there? Okay, so that's 5 times 4x. And 5 times negative 3. When we do 5 times the 4x, that's going to get us 20x. When we do 5 times negative 3, that gives us a negative 15, so it acts like a minus 15, and that is equal to 25. Then we just have our 2-step equation to solve from there. We would add 15 to both sides. That's going to leave us with 20x is now equal to 40. And then we would divide both sides by 20. And get x is equal to 2. Okay, for problem number 5. Problem 5, what did you get, Cole? F equals negative 3. Very good. Go ahead and put the yo-yo away, please. Okay, so we have a 2 that's on the outside. We need to go ahead and distribute it to the 6f and to the positive 4. So that means we're doing 2 times 6f, and we're doing 2 times 4. 2 times the 6f is going to come out to 12f. 2 times 4 comes out to a positive 8, and the whole thing is equal to negative 28. Okay, now we go ahead and start by solving with subtracting 8 from both sides. That starts the process of isolating the f. We're left with 12. F is now equal to a negative 36. And then the last step is to go ahead and divide both sides by 12. And we'll get f is equal to negative 3. Okay, and then for problem number 6, Caleb, what'd you get? Y equals 1. Very good. Okay, so again, you're just going to distribute. You're going to do negative 6 times 3y, and then you're going to do negative 6 times negative 7. Okay, so that gives you a negative 18y, and then a positive 42, because negative times negative is a positive, and it equals 24. From there, we can then subtract the 42 from both sides. That's going to leave us with negative 18y is now equal to negative 18. And then we would divide both sides by negative 18 and get y is equal to a positive 1. Okay? So problems 7 through 9, those are going to be our combining like terms, so we have to simplify before we can solve. Aaron, what did you get for number 7? X equals 5. Okay, so the first thing that we're going to do is combine any like terms that we can. So we happen to have a 3x and a 6x, so I'm going to combine like terms, CLT, combine those like terms. When I combine those together, that gives me 9x. So I now have 9x is equal to 45, and then it's just a one-step equation. From there, we just divide by 9, and we'll get x is equal to 5. Okay, for problem number 8, what did you get for number 8? We'll go with Brian. Brian, what did you get for number 8? 6. Very good. Okay, so again, we're going to combine those like terms together first that we can. So we happen to have an 8x and a positive 3x that can get combined together. So 8x plus 3x, that's going to come out to an 11x. Then we also happen to have a positive 15 and a negative 24 that can get combined together. 15 minus the 24 is going to come out to a negative 9, so it acts like a minus 9, and the whole thing is equal to 57. Then it's just a two-step equation from there. You're going to add 9 to both sides. That's going to leave you with 11x is now equal to 66, and then you would divide both sides by 11 and get x is equal to 6. Okay, do you have a question? No, you want to answer? All right, go ahead. Gymnast, what did you get for number 9? X equals negative 3. Good. All right, so again, combining those like terms, we have 5x and a positive 2x that we can combine together. 5x plus 2x. We also have a negative 11 and a negative 15 that can get combined together. Okay, when we add the 5x and the 2x together, that gives us 7x. When we do negative 11 minus the 15, that comes out to a negative 26. And the whole thing is set equal to negative 47. Right, from there, we're just going to add 26 to both sides. That's going to leave us with 7x is now equal to a negative 21. And then we would divide both sides by 7 and get x is equal to negative 3. Okay, and then we have our last set of problems that we covered from equations, which is those variables on both sides. Remember, we don't do variables on both sides, so therefore we have to move one of the variable terms over to the other side. A lot of you struggled with that with our recent test when trying to rewrite like standard form into slope-intercept form or vice versa. So you need to make sure you remember when moving a term, whether it's a number term, like I moved 8 over to the other side, you add or subtract it. You do the opposite. It's the same thing when moving a variable term. You add or subtract the variable term to the other side as well. So in this case, I'm going to always try to go ahead and just move everything over to the left. Okay, that's what I want to go ahead and focus on doing. I'm just going to move all of my terms over to the left, my variables to the left, my numbers to the right. So for here, I would just subtract my 2x from both sides. Okay, by subtracting 2x from both sides, the 2x's can cancel out. 8x minus 2x now gives me 6x. I still have this plus 3, and it's equal to a negative 9. Then I can subtract a 3 from both sides. That's going to leave me with 6x is now equal to negative 12. And then the last step is to go ahead and divide both sides by 6, and we'll get x is equal to -2. Okay, what about for problem number 11? What did you get for number 11? Elijah?
3.
3, very good. Okay, so again, same idea. You're just going to move one of your terms over to the other side. I'm going to subtract 4x, because I want to move all my variable terms over to the left. So I'm going to subtract 4x from both sides. Negative 9x minus the 4x is going to come out to a negative 13x. So we have negative 13x plus 12 is equal to negative 27. We can then go ahead and subtract 12 from both sides. That's going to leave me with a negative 13x is now equal to a negative 39. And then we can divide both sides by negative 13 and get that x is equal to positive 3. Eker, go ahead and finish this out for number 12. What did you get? X equals 5. Very good. Okay, so we're going to add 7x to both sides, because that was a negative 7x, so now we're going to add 7x to both sides. Negative 3x plus 7x comes out to a positive 4x. We still have a positive 11 is now equal to a positive 31. We can then go ahead and subtract 11 from both sides. That's going to leave us with 4x is now equal to 20. And then our last step is to divide both sides by 4. And we'll get x is equal to 5. So just reviewing over all the different kinds of equations that we have to solve. You need to know how to be able to do all formats, because you're going to be using them all for over the next couple of days with our angle relationships. Now, yesterday, you guys should have completed your iReady lesson on angle relationships. It kind of gave you just an introduction to them. We're going to go over them a little bit more thoroughly today in class. So go ahead and flip your paper on over to the back. So we're using angle relationships today to be able to solve for any missing angles, and using any form of equations. It might be a one-step equation, two-step, it could be multi-step, it could have variables on both sides. But first thing that we need to know is the type of relationships that we are dealing with. So when we're talking about a relationship must have at least 2 angles involved in order for there to be a relationship, right? Just the same thing as when you have a relationship with a person, it's you and somebody else, okay? Friendships are considered to be relationships, so it's you and someone else and maybe multiple other people involved in that friendship, but there's more than just one person involved. It's the same thing with relationships in geometry. There's more than one involved. Okay, so when we talk about a relationship, we're talking about a combination of several angles, at least 2, that are going to form a certain degree. So the first relationship we have here is complementary. So when we talk about complementary angles, these angles have a sum, meaning that you are going to add a sum, and it's 2 or more angles that are going to equal 90 degrees. That sum is going to equal 90 degrees. So that means you cannot have a 90-degree angle inside of a complementary relationship, because if you already have a 90-degree angle, then any other angle paired with it will not let it equal 90 degrees. So you have to have 2 acute angles, 2 or more acute angles that can combine together to have a total sum of 90 degrees. So for example, if this was x and this was y, then that means that when we take the value of x and add it with the value of y, that's going to be equal to 90 degrees. Okay, and we note that by the fact that this measurement, this little box in the corner, indicates that this is a 90-degree angle that's formed when they're pieced together. Okay, and it's easy to see 90-degree relationships as well because they look like the L. All right, then we have our supplementary angle relationships. So for supplementary angle relationships, again, it also has a sum, so that means that you are adding all of these angles together, and that total sum is going to equal 180 degrees, 180 degrees. So again, if this was our x and this was our y, then when we take the x and we add it with the y, it's going to equal 180 degrees. When we take our x and add it with y, it's 180. It's a little difficult to see. Let me go over it with a pen. Now, every year, kids get these 2 vocab terms confused. They're like, oh, complementary 180. No, complementary is 90. Supplementary is 180. So over the years, I've had kids come up with different mechanisms to being able to remember that complementary adds to 90 and supplementary adds to 180. So one of the common mechanisms kids use is they look at the words complementary and supplementary in alphabetical order, and then 90 and 180 are in numerical order. So complementary comes before supplementary in the alphabet, and 90 comes before 180 on a number line. Does that make sense? So 90 and complementary come first, supplementary and 180 would come after. Another one that one of my students came up with is they said, if I give you a compliment by saying you're always right, I'm paying you a compliment by telling you you're always right. So forming a right angle is complementary angles. Yeah. Nope, it has to be exactly 180 when you combine them together. So these relationships are very, very specific. Okay, if your relationship, if your multiple angles are combined together and they do not equal 90 or they do not equal 180, then they do not have one of these two relationships. They still have a relationship. They might just be adjacent angles, which we'll talk about that later. They might be vertical angles if they're exactly equal to each other. Okay, there's all sorts of different kinds of relationships, but they also could have no relationship whatsoever. Okay, yeah. As long as it would all add up to 90 degrees. So now obviously they're not going to have a whole bunch of them. I think the most that I've seen on any question was that they had a series of 4 angles to equate out to 180 degrees. But for the most part, they focus on 2, 3, and again, sometimes maybe 4 angles that'll form those relationships. Okay, another easy way to be able to identify your supplementary angles. Supplementary is a straight line that it forms. When you pair your angles together, it's going to create that straight line. So supplementary straight. Okay, complementary is you're giving a compliment, it's right. Okay, and then we have our last relationship here. Our last relationship is the vertical angle relationship. So vertical angles are formed by intersecting lines. That's really important to note. They have to be formed together by intersecting lines, and they do not share a wall or a common ray. Okay, it's also important to note that they are congruent to each other, meaning that they are equal to each other. So the best way that I can tell you guys to think about it is if you are at your home, you have how many next door neighbors to you? At most, how many next door neighbors can you have? 2, right? You can have a next door neighbor that lives directly on your left side. You can have a next door neighbor that lives directly on your right side. Okay? So you can have at most 2 next door neighbors. We call that adjacent. Okay? So I want you to actually write that down up at the top. If we have adjacent. Adjacent means that they are directly next door. Adjacent means that they are going to be directly next door to each other. They do not have to have an angle requirement, like a measurement requirement. They just share a common ray. So X and Y in this case are adjacent to each other as well as complementary. They're adjacent because they are directly next door to each other. They share a common ray, and they also happen to equate to 90 degrees. Same thing with this X and Y. They are directly adjacent to each other because they're right next door. They share a common wall. And then they also happen to be supplementary because they equal 180. Not all adjacent angles are going to equal 90 or 180. They might not equal anything at all. They just might be adjacent. Then you've got vertical angles. So when you're living in a home, you might have a neighbor who's right across the street from you. But you can only have one person who's directly across the street from you. Okay? If they're slightly to the side, they're not directly across the street, right? That would be they're slightly to the side, slightly to the left, or slightly to the right across from you. But you could only have one home that could be directly straight across, meaning if I leave my driveway and just walk in a straight line and can go right up their driveway, okay? That would be what we call a vertical angle. They are across the street neighbors, okay? So you can only have one across the street neighbor. So let's call that, they are across the street neighbors. So adjacent neighbors and directly next door neighbors, you can have two. Across the street neighbors, your vertical neighbor, you can only have one. So taking a look here at this diagram that we've got, we have several different angles. We've got 5 different angles, okay? If we are looking for some vertical angles, then the measurement of X and R, they are directly across from each other. They are directly across from each other. So angle X is equal to angle R, or congruent. We'll put our congruent symbol. They are congruent to each other, therefore they are vertical pairs because they are directly across from each other. Now, as for adjacent neighbors, so this is my vertical. If I wanted to talk about adjacent pairs, then angle X and angle M are adjacent to each other. Angle X and angle M, that's one pair. We also have angle M and angle B. They are adjacent neighbors. We also have angle B and angle R. They are adjacent neighbors. And then we have angle R and angle F. They are adjacent neighbors. And then our last other pair is angle F and angle X. They are adjacent pairs. Okay, I just tried to put different symbols so that you could see how they're all connecting differently. They are side by side. They are directly next door to each other because they share a common wall. Caleb? No, they are not vertical because can I draw a straight line from F that would connect, that goes through the vertex and then connects me to M? No. So like I said before, with vertical angles, it has to be directly across the street, meaning you have to form a straight connection that goes through the vertex to connect you. If I were to draw a line starting at F going to the vertex, it would then have to curve to go to M, or it would have to curve to go to B. It would not be able to be a direct straight line, okay? Now, the combination of M and B together is a vertical relationship to the value of F. But those angles themselves are not directly vertical angles, okay? Just their combination would be. All right, any other questions? Okay, so let's take a look here. The best things that you can do is identify the kinds of relationships that you are dealing with before you start solving for any angles missing measurement. So the first thing that I'm going to note here is that problem number 1, these are considered to be vertical angles. And since they're vertical angles, that means that they are equal to each other. So that value of 2x is going to be equal or congruent to the value of 70. So when I'm creating an equation, I'm just going to put 2x is equal to 70 and then solve from there. So 2x equaling 70 means that I can go ahead and divide both sides by 2. And I would get that the measurement of x is 35. Again, all vertical angles are directly across from each other, formed from these intersecting lines, and you would set their equations equal to each other. Go ahead and do problems 2 through 4 on your own. You can tell me what they got for value of x for problem number 2, James? X equals 52. Good. Okay, again, these are all vertical degrees, vertical measurements here, so they are going to be equal to each other. We do have 3x minus the 1 is equal to 155. Okay, the first thing that we're going to go ahead and do is just add 1 to both sides. Okay, adding the 1, that's going to give us 3x is now equal to 156. And then we can go ahead and divide both sides by 3, and we'll get that x is equal to 52. Okay, what about for problem number 3? What did you get for your value of x, Sophia? X equals 7. Good. So we have x plus 16 is vertical to the 4x minus 5. Doesn't matter how I set it up. I could put, x plus 16 is equal to 4x minus 5, or I could do 4x minus 5 is equal to x plus 16. It really doesn't matter. I'm just going to go ahead and put 4x minus 5 is equal to x plus 16. The only reason I chose to do it that way is so that the larger value of x is already on my left side. Makes it a little easier, less likely to deal with negatives. So I'm going to go ahead and subtract an x from both sides. Remember, when I'm subtracting that x, it's like subtracting a single value of 1. So 4x minus 1x is going to give me 3x. I now have 3x minus 5 is equal to a positive 16. Okay, and then I can go ahead and solve from there. I can add 5 to both sides. That'll give me 3x is now equal to 21. And then I would divide both sides by 3 and get that x is equal to 7. Okay, and then for my last one, problem number 4, what value of x did you get? Lydia? X equals 3. Good, so I have 12x plus 10 is equal to 5x plus 31. So 12x plus the 10 is equal to 5x plus 31. Okay, so I'm going to go ahead and subtract 5x from both sides. That's going to leave me with 7x plus 10 is equal to 31. I would then go ahead and subtract 10 from both sides. That leaves me with 7x is equal to 21. And then the last step is to divide both sides by 7. We'll get x is equal to 3. Okay, any questions so far? All right, let's go ahead and flip it on over to the last page. That last page is going to be us dealing with our different complementary and supplementary relationships. So for problems 1, 2, and 3, I want you to tell me whether the pairs that we have here would be considered complementary, supplementary, or neither. It doesn't have to be complementary or supplementary. It could have no relationship in that regard. Did you already do it? Okay, just wait. Go ahead and take, a minute to figure those out. So problem number 1, we have 53 degrees and 127 degrees. Is that complementary, supplementary, or neither, guys? Supplementary. Kingsley's like, I didn't say that out loud. That was somebody else who vocalized it. It would be supplementary, right? If we take 53 and we add 127 together, that does equal 180, which is supplementary. All right, Cole, calm down, honey. You don't have to be obnoxious. All right, what about for problem number 2? Complementary, supplementary, or neither? Complementary. Okay, it's super comp, really. 56 plus the 34, that is going to come out to 90 degrees. That would make it complementary. All right, and then the last one is? Neither. Okay, if you were to take 30 and add 39, you get 69 degrees. That is neither. All right, let's take a look here. So again, just like we did with the vertical angles, take your seat. Just like we did with the vertical angles, we can use the angle relationships to be able to create these equations here. So if we're taking a look at problem number 1, I know that this is a complementary relationship, even though x is missing. I know it's complementary because of the fact that we do have that right angle measurement inside of here. That right angle measurement indicates that these two angles formed together are creating that right angle, that L shape here. Okay, so I do know that these are going to be complementary angles. So when I set this up, I can set it up as angle X plus angle 68 needs to be equal to 90, and then I can go ahead and solve for X. I would just subtract 68 from both sides and get that the measurement for X is going to be 22 degrees. Okay, if it happened to be a supplementary pair, like problem number 2, problem number 2 is a supplementary pair because, again, together, when I'm putting these measurements together, they are forming a straight line. If it forms a straight line, then we are dealing with a supplementary angle relationship. So that means I can take 2x, I can add it with 36, and that should equal 180 degrees. And then I would go ahead and solve. I would subtract 36 from both sides. That leaves me with 2x is now equal to 144. And then I would divide both sides by 2 and find that x is going to be equal to 72 degrees. Okay? What I want you guys to do for problems 3, 4, and 5, you're going to solve for the values of x, or in this case for problem number 3, you got to solve for x and you got to solve for y using your angle relationships that you know. And yes, you could still use vertical as one of those angle relationships. So here we're going to go over it real quickly. The first relationship that I do seem to have here, I can solve for x right away because of the fact that 2x and 120 are forming a supplementary relationship. So for 2x and 120, those are supplementary. So I can do 2x plus 120 is equal to 180. I can set that equation up. I would solve by subtracting 120 first. That's going to give me 2x is now equal to 60. And then I would divide both sides by 2. Just wait, do not pack up. Sit back down.
Sit down, sit down.
If you start packing, you are going to have silent lunch. Okay, so we can get x is equal to 30. Then I can also create a vertical relationship by the fact that I do happen to have two intersecting lines. We have 3y plus 30 is equal to 120. So 3y plus 30 is equal to 120 because these are vertical angles. So then we can solve by subtracting 30 from both sides first. That's going to give us 3y is now equal to 90. And then we would divide both sides by 3 and get that y is going to be equal to 30. Okay. For problem 4 and 5, I want you guys to go ahead. You're going to do those as your homework tonight.